Okay, this next concept is called monic quadratic trinomials in the factorizing topic. And if you look at the name as it suggests, okay, you've got monic, these are called monic quadratic trinomials. And so the word monic means one. And so if you have a look in front of the pronumerals, like question 1, you can see in front of this x squared, there's no number. In other words, there's a 1. In front of this, there's a 1. In front of this, there's a 1. In front of this. So the coefficient of the squared is always a 1. So if you look at this entire page carefully, you'll always see that there's a 1 in front of the pronumeral of the squared. Just quickly, I'll show you the next page. These are called non-monic because in question 1, for example, you can see there's a 2 in front of the x squared, there's a 5 in front of the t squared, there's a 6 in front of the y squared, etc., etc. So, monic, that's what monic means. Quadratic. Quadratic because the highest power is a squared. So question 1a, it's x squared. That's why they're called quadratic. And trinomial because in these questions, there are always 3 terms. So that's 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay? So that's the format. That's what these questions look like. There's always 3 terms. Let's cut that out now. So it's very important because what's going to happen in exams is you're going to get, the question's going to ask you to factorize, and you must be able to identify what type of factorizing question it is. Is it a grouping in pairs? Is it a difference of 2 squares? Is it a monic quadratic trinomial? Or is it a non-monic quadratic trinomial? Once you've identified what type of question it is, then you can answer it. Okay, so question 1a now. So what do you do in these questions? Well, it takes a little bit of practice, but the concept is actually quite easy. What you have to do is find 2 numbers that multiply to give the number on the end and add to give the middle. In other words, what 2 numbers do you multiply to get 12 and add to give 7? And those numbers are 3 and 4. Because 3 times 4 is 12 and 3 plus 4 is 7. So the numbers are 3 and 4. So you open up 2 sets of brackets. You put in x and x because in the question it's x squared. And because our special numbers are 3 and 4, we're going to put a plus 3 and a plus 4 here. And that's it. And the order doesn't matter. Okay, let's go on now to the one underneath. Question C. What numbers multiply to give 2 and add to give 3? Well, this is a very easy one because the only numbers that multiply to give 2 and add to give 3 are 2 and 1. 2 times 1 is 2 and 2 plus 1 is 3. And that's done. Let's go to the one underneath. And because in the question it's a y squared, we're going to put a y here and a y here. So what numbers multiply to give 12 and add to give minus 7? Now, if you think about directed numbers and positive and negative numbers, the only way you can get 2 numbers multiplying to give a positive, but when you add them you get a negative, is if they're both negative. Okay, so a negative times a negative is a positive, and a negative plus a negative is a negative. So our special numbers are going to be minus 3 and minus 4. Because minus 3 times minus 4 is 12. And minus 3 plus minus 4 is minus 7. Okay. So the actual concept itself is very easy to understand. However, to become really good at this, you have to do a lot of questions. And I've often said to students, you've got to sit there for at least an hour and just answering one question after another. And with practice, you become very good. Let's continue on down and do a couple more questions on this page. So open up two sets of brackets. Two numbers that multiply to give 9 and add to give 6 are 3 and 3. Because 3 times 3 is 9 and 3 plus 3 is 6. Let's go to the next one. Our pronumeral in this case is n squared. So we're going to put an n and an n. So now, what numbers multiply to give minus 3? Let me show you where students can go wrong here and how to be careful. The numbers that multiply to give minus 3 are minus 3 and 1 or 3 and minus 1. Okay? So minus 3 times 1 is minus 3. And 3 times minus 1 is also minus 3. So both the first one and the second one multiply to give minus 3, which is perfect. Now don't forget, our numbers, when you add them, have to give the middle number, which is 2. And if you add these two, you get minus 2, which is incorrect. But if you add these two, you do get 2. So these are our winning numbers, 3 and minus 1. So just to recap, 3 times minus 1 is minus 3. And 3 plus minus 1 is 2. In other words, they're our correct numbers. So we're going to put plus 3 and minus 1. The order doesn't matter. I could have rewritten this as the minus 1 first and the plus 3 afterwards. It's not going to make a difference. Okay, I think there's a problem with one of the questions on this page. Question G, this one over here. That is not a monic quadratic trinomial. Okay, so that one there probably shouldn't be there. That's just a normal factorising question. Take out x and you're left with x minus 12. It's just taking out the highest common factor. Actually, even 3a as well. Okay, they're just normal factorising questions. Question 3c. When students are often starting this topic, they get a little bit confused here. If you look at 3c, you've got t squared minus t minus 6. Really, in front of the t, there's a 1 there that you can't see. 1 is a coefficient of everything, so you can do that. So now what numbers multiply to give minus 6 and add to give minus 1? The numbers are minus 3 and 2. Because minus 3 times 2 is minus 6. And minus 3 plus 2 is minus 1. So there are our special numbers. So again, we open up two sets of brackets. We're going to put t and t because that's our pronumeral. And we're going to put the minus 3 and the plus 2. The rest of the page is identical. Okay, you don't do anything different here. Again, you just got to spend time practicing and really trying to get the right combination of numbers. You can get a little bit frustrated when you first start these, but the more questions you do, the better you get, just like most concepts in maths. Okay, that's monic quadratic trinomials, and we will shortly move on to non-monic quadratic trinomials.